Okay, so we're going to get started. Just as a reminder, for most sessions of this class, we're going to begin the class with a 10-minute, typically, occasionally 5-minute introductory scrum. This scrum period is designed to allow the teams to meet to sort of resync your understanding of the current state of things. You can discuss what you've done since the last time you met, priorities for what you're going to do next, exchange information as needed to resolve issues that have come up, etc. I'm making an exception to that today for two reasons. Number one, we're going to have a discussion of projects, potential projects today, and particularly in the tutorial, and so it seems a bit preliminary for have you folks sort of exchanging information prior to that, particularly since the tutorial this afternoon will be a chance to sort of talk with each other, exchange information, etc. Number two, I'm going to take a brief period of time to talk about one of the projects within this particular session. There's going to be two other descriptions of projects this afternoon associated with the tutorial, where you'll hear about two other projects, and then you'll sort of be free to talk. You can ask questions of the people presenting project ideas so that you get some understanding of concrete issues associated with the system that they envision. And then you can talk amongst yourself as teams and decide which of those projects is of greatest interest to you. You can, of course, and I'd encourage you to follow up with additional questions or meetings with some of the stakeholders so that you can develop confidence that this is a path you'd like to go down for one of the projects. Ultimately, you want to settle on a project within the next week or so. Okay? So you might want to meet with a couple stakeholders, find out more in depth sort of what they have in mind, talk with them about what an incremental rollout will be of the sort of system that they describe. I emphasize incremental because it is required as part of the course that it be broken up into at least 4 successive deliverables which elaborate on increasing functionality, each of which should typically be fairly robust. Robust in supporting a subset of features, to be sure, but stable, able to be passed before the stakeholder for feedback without fear that it's going to, turn over on its back and die in front of them, and stable enough to admit to some testing by myself and markers. So with respect to these meetings, they'll be up for you to set up, but today's brief pitches will give a first opportunity to learn about some of these ideas. Okay. So I have posted to the course website a couple things. One thing is slides from the last lecture that I gave. And a sort of preview of the slides that I'm going to be working off of today that you may find helpful. I had trouble uploading that in time for last class because of the size of it, so I had to put it externally. Another important thing that I did upload was a 1 to 2 page brief on 4 of the projects I gave us, 3 or 4. I think it's 3 projects at this point, which you might want to look over ideally prior to this afternoon's meeting at the tutorial, because there'll be 2 presentations there. So if you can get a chance to look at that, it will be an opportunity to learn a little bit more about what's envisioned, so you can ask more intelligent questions prior to that tutorial. Okay. Now, another thing which we did since last time, and for which I'm grateful for your feedback, is to talk about alternative times for the tutorials. You'll recall that I had typically for this course scheduled the tutorials on Wednesdays, 4 to 5 p.m. And for whatever reason, that was changed this semester in a way that I wasn't alerted to early on. And by the time I did know about it, it was in the course calendar. I asked for feedback from people here as to the times they're free. And the results don't look pretty. So if we go and we look at this, you can abstract over the names on the left-hand side, particularly participant 14 down there at the bottom. But what you'll see is a slow pan of unavailability. This puts me in a bit of a bind because the slot which has the largest amount of free time, which is indeed just prior to the slot that's currently allocated, still is missing 4 individuals, which when I took the poll last time seemed to be worse than the situation for the current tutorial. So I'd like to ask one more time, just to clarify my understanding. The current tutorial time for this class is scheduled from 4 p.m. to 5 p.m. How many people cannot make the entirety of that time? In other words, you have a conflict for at least a sub-piece of that time. I should raise my hand because they scheduled it in a way that conflicts with another of my courses. And I'm afraid with 3 versus 4, we're going to have to actually leave it like that. Yeah.
Is it possible to push 394 half an hour later than what it's scheduled to start at? Because it starts at 4:30, right?
Yeah, right. So that's a dynamite idea.
We could ask that later.
I think I'll do that. Yeah. I'll ask. So my other course is 394. It's a simulation course, and it has a smaller number of people, so it might be an easier scheduling problem. So we'll see if we can push that back till 5, in which case at least 2 people's issues be resolved, although not the third, unfortunately. So we'll see what we can do, but right now, steady as she goes. We're gonna have to stick with the, I think, appointed time. And this afternoon, the presentations by the stakeholders will be in that time slot. Please bear in mind, when it comes to your team projects, that you shouldn't count on that as your only time to meet. You should be meeting other times each week, and most notably, make good use of these lectures. That 10 minutes can be really helpful, because it can be devilishly hard, as judging by this, to get your whole team together. Even if you were to subdivide this and to half the class at a time, you'd still have a really nasty scheduling problem. So anyway, that's the administrative for the tutorial. We'll see what we can do to further work on this. Any questions right now? Okay. So what I think I'm going to do first is to actually talk a little bit about about one of the project ideas. It's one that's in no way privileged, but it did come from some discussion of myself and several other faculty about functionality that would address needs in their research or personal interests. And I'm going to put it here at the beginning of this lecture just so it doesn't fall off the end at the end. Okay? The project here would have me as a primary stakeholder to be meeting with me, which has pluses and minuses. I suppose I'll let you folks judge most of the minuses, but one of them would be that you'd be working with someone who's also looking over your implementation and code base. That may be desirable, that may be undesirable. There's many types of stakeholders in the world when it comes to building real-world projects. And I've had my opportunity to work with very, very technical individuals, and also to work with people who have very, very little knowledge of computer science and software development. In this case, you'd be meeting with someone, myself, who's quite knowledgeable. I might give you suggestions technically about how to approach things, how to decompose things into several incremental deliverables. In other projects, you'd be the ones probably judging that yourself, which might have some real advantages. But in any case, I would serve as the primary stakeholder. There'd probably be some others who meet in the course this semester. The project would involve smartphones. Smartphones like this. This is a sort of a iPhone knockoff Android phone. This is an Android 4 phone that looks oddly like an iPhone. And we have a set of Android phones which we work with as part of our research, and we hope to make at least a few of them available for a team, and to build an Android app, which would be met with on the web side a web application, which would operate another sort of interface. So there'd be a web app and then another web-based interface. And the goal of this would be something might be called geo-crowdsourcing. Anyone hear of crowdsourcing before? What is crowdsourcing, Ridley?
It's where you get, it's basically mass distribution. You get a large amount of people to perform some tasks. So
Exactly.
it could be like Kickstarter, the famous example where large people contribute small amounts of money to fund a project.
Yep, exactly. So that's a great example. There's Mechanical Turk, the Amazon Mechanical Turk, where you can farm out a problem to be worked on people worldwide, by people worldwide. There's other applications where you'll have people contributing information about observations and what have you. And the goal here would be to crowdsource a very particular sort of thing. And that would be geotagged information, okay? So it'd be sort of geo-crowdsourcing. And the information would be particularly focused around images or videos of activities, okay? So here on the smartphone, you'd have some individual with an Android smartphone who might see something of potential interest to a particular effort of this sort. So a particular channel you might be associated with this effort. And this effort might be focused on collecting images associated with tobacco advertising, if you're interested in sort of health effects that impact people. Another example is it might be people interested in wildlife sightings of interest, unusual wildlife within Saskatchewan. Another interest might be unsafe sidewalks in a community, something like that. Another, maybe more aimed at community policing, would be photographing instances of vandalism or potential suspicious activity in the neighborhood. Now, all of these things would be distinguished by the fact that they're activities being noted at a time and at a place. Okay, so they're taking place at some point in the landscape, at some point in time. And someone with a phone should be able to take an image of this quite quickly, or take a video, if you will. There may be some additional information that's filled in at that time. Maybe it's information which describes what was going on leading up to that event. Maybe it's information on sort of associated characteristics that couldn't be determined directly from a picture. For example, information about the texture of a mushroom, or a collection of additional images that further document the situation. And so the idea is on the smartphone, on this app on the smartphone, you'd be collecting some information, and most critically, it will be geotagged. Okay, so it's occurring at a point in time and at a point in space. And this information would get batched up on the smartphone. A given person will maybe take, say, they're walking in the Nisbet Forest, and they take photos of three interesting wildlife species. Maybe they're ducks or something like that for people interested in birds. And you get those images, and maybe they're out of cell phone range at the time, and so they're just batched up on the phone. And when they come back into cell phone range, or maybe immediately if cell phone connectivity was available, it uploads it to a server. Okay, so there's some server which it's going to upload this information for. And so there'll be a bunch of information on these incidents associated with a particular channel. Each incident might be associated with a channel specific to a particular interest. So wildlife in Saskatchewan would be one channel. Riversdale safety issues, street safety would be another channel. Another channel might be, boreal forest mushrooms in Saskatchewan, what have you. So this information is uploaded to a server. And then people, over time, could come to a web app and browse that information. Now, the interface to be used for this, I'm not particular about. This may leverage Google Maps. It may make use of existing past efforts which have used geo-sourced images. It may, in fact, ride atop of Google Earth or Virtual Earth by Microsoft or what have you. The point here is in this web app, you'd be able to view some landscape and be some region of space. And critically, you'd be able to delineate a period of time that you're interested in looking at. So this might be a specific set of concrete dates, like July 1st through July 31st, 2013. Or it might be a generic time period that's a subset of the year. Maybe it's July of any year, if you're interested in seasonality. So birds during migration season or what have you. So you might fill this in with July, and it will show various images that were collected for that sub period of time. So these might be images collected in July of different years, and you'd be able to go hover over these, see a bit of information on this particular incident. You'd be able to click on it and get further information that might include images, might include additional textual annotations, etc. And depending on the permission settings applied here, you might be able to further comment on it. For example, you might be able to offer suggestions onto the identity of a plant that's depicted. Maybe it's a type of flower or a mushroom. You might be able to comment on a particular animal. That this is clearly an elk, a buck elk, or what have you. You might further correct some information. So if you're the person who submitted it, you might add some additional germane information. There might be some additional fields which are commonly provided, which would, for example, when you submit it, there might be a field for all things that you submit that asks whether you're seeking advice on identification, in which case some of these might have a certain visual indication that indicates advice is sought. And so that if you're an expert in ungulates of Saskatchewan, you really know your cervids, your mule deer, and your white-tailed deer, and your moose, and your elk, and your caribou really well, you might be able to quickly go and sort of comment on these various images and what they depict. If you're an expert mushroom hunter, you could go in and sort of comment, okay, edible, not edible, you die if you eat this one, that sort of thing. And so the point is that you would go in and look at these things. Now, each image would normally be tagged by the person who submitted it, but for a given channel, there might be an option of anonymous submission. So the idea is if you have a channel where certain things are sensitive, if you're depicting potential crime incidents, or depicting people going through red lights or something like that, you might allow for anonymous submission. The goal here would serve many purposes. There's some groups that are interested in crowdsource images because they do routine bird counts every year. And so there's an Audubon-based bird count where you participate in bird counting on a certain day of every year, and it's a very routinized thing. In other cases, there may be real scientific value conferred. So it turns out that many things within the boreal forest are understudied. And mushrooms in particular, as you'll hear this afternoon, are not really well known in Saskatchewan. They're There have been some books on it and so on, but there's many discoveries to be made. And a scientist interested in understanding patterns of health, or in understanding ecological patterns, understanding patterns associated with crime in a community, could use a system like this, particularly as more and more images, more and more incidents get recorded. They could utilize this to understand trends. You might be interested in, for example, for a given region, what species of flowers are there at different seasons. That's not something that is easy to just notice, because at no one time do you see them all. But you might be able to essentially go through several periods of time and notice for the same region, you see these different flowers popping up at different time points. If your interest were in sort of understanding the diversity of wildlife in Saskatchewan, something like this could really contribute a great deal of information. If you're interested in community safety from the standpoint of the police, this could lend understanding. Or for municipal authorities, decaying sidewalks, instances of vandalism, unplowed bike paths. I could contribute a lot of images for those that you want to alert people to as soon as possible so the city cleans up its act. This would be a way to sort of secure feedback from large numbers of individuals. It's cheap, can be run on top of standard hardware. It should be able to be invoked very quickly from the smartphone side, and it should allow for public browsing, except where you want to annotate things or change things or delete images of your own. You'll need to log in. In that sense, it's quite like Panoramio or PhotoSend, where you can go there, you can browse things, and you can log in if you wish to access private information. When you're submitting some incident record there, maybe by default it's public, but you should be able to designate, is this private, is this for me only? Maybe should I share this with a Google Plus circle of friends or what have you? So a component which from the user's perspective involves two interfaces. The smartphone interface should be quite simple. It should be sort of very easy to fill out. Now, what I haven't described yet is, okay, we have these channels. They're collecting information on different things. The mushrooms of Saskatchewan, the ducks within North America. It could be incidents of vandalism in the city. It could be late buses, in the city. How does it record information for this diversity of categories? Well, probably for a given channel, there needs to be some specification of what information needs to be collected. And I have some information on the sort of two-pager that briefly describes this. What I see is probably being provided as some sort of schema. Maybe it's in the form of an XML specification, which indicates sort of the fields that have to be collected. So there might be one image, or maybe a couple images. Maybe if you're photographing a plant, you want an image of the bark, you want an image of the underside and the upper side of a leaf, and you want an image of any sort of reproductive machinery like the catkins or what have you. So for a given channel, there'd be associated schema of sorts, which would define what sort of information needs to be specified for that. And administrators, through a separate administration interface, would be able to set up a channel where this sort of information is specified. Now, for the sake of this project, I have a suggested sort of series of 4 incremental deliverables that I think could work with this, that are pretty sort of mild. And it may be that you don't try to make it a fully general system up front, that you try to sort of test it out with one particular application for the course of the semester. Or it may be that you want to put more emphasis on the generality and you want to go less deep in terms of the interfaces. I'm open to either way. But the point is that ultimately, if a system like this were to be successful, you'd want a lightweight way that someone could come set up a channel, say, this is the sort of information I want. There's this mandatory checkbox which indicates, whether or not this is poisonous. There's 3 images required, of each thing, or I want a video instead of an image. And there are these other fields which are text boxes or which are numbers. And that admin interface would allow you to set up a channel. And then smartphone app would essentially subscribe to a channel. You'd say, okay, I want to opt in to mushrooms of Saskatchewan. I want to opt in to Saskatchewan transit pathologies. I want to opt into this bird Audubon's bird census or what have you. And you'd be able to opt into those things. And when you snap an image of some incident up front, very quickly, you could then select which channel you want to submit it, and it would prompt you for additional information that you'd want to fill in. So that's kind of the app as I see it. There's many exciting applications of this. I see applications in health sciences, medicine, ecology, environment, geology, etc. Imagine being in the field collecting geological specimens, or in the field collecting archaeological specimens. Dinosaur bones, if you're a paleontologist, all the way up to people interested in real risks to people's health from tripping or what have you on an uneven sidewalk. This is a crowdsourcing image app that would leverage the large number of people out there who care about an issue. Maybe not most people, but a given issue, there might be 1,000 people in the city, and pretty quickly those people could cobble together a lot of information about what's going on if they could have this at their fingertips. So an admin interface, which you might want to go later on for the course of the study, a smartphone app interface, Android, I think the obvious way to do it, and then a web app which would gain access to some of this information. What I presented here, as you'll hear this afternoon, is more of a long-term vision. There'd be a desire to scale this down into very baby steps that could be done over the course of 4 successive deliverables, where for each step there'd be some value conferred. So even if you were to stop halfway through, stop after iteration 1, and the team just flounders around, you'd still have gotten some value out. And I have a plan which I think could probably lead to that. So that's sort of a crude description of the vision. Any questions on that? I'm just the first of several people will be pitching a little bit. Questions? Okay. Wish I could say you can keep these, but we don't have that option yet. But be a great system if it could be built. I think you'd see a lot of potential users. Okay. So that was the first of them for today. What you're going to see this afternoon is 2 other presentations planned. It's possible we'll have a cameo by someone else who will give 2 additional yet. Those will be from other stakeholders who will try to expose you to their visions. Okay. The main goal of today's lecture, though, is to discuss best practices. Best practices in software development. And these are practices which, by and large, you require as part of your projects. And you see that spec'd out in the syllabus. We're going to go through these at really high speed because we're going to cover them in greater depth later on, and it's important that you know what they mean. You have some sense of what I'm looking for as soon as possible, because come deliverable 1, I do want to see these in place. So the goal of this is to do greatest hits. The goal of it is to kind of give that high-level overview that will let you have some understanding of what's being looked for. So we're going to talk about a couple of these things. Some of them are more technical in nature, and some of them are more process-oriented in nature. The first of them here is more technical, and it has to do with the use of assertions. How many people have used assertions before within your programs? Okay. Was that something you were exposed to in 370? Okay. So where did you see it? 214? Okay. Professor Duchin? Okay.
It was more or less
assertions in that context, there's two uses of this terminology, assertions, that you'll find circulating in the department. One is as a way of specifying specifying conditions, preconditions, postconditions, for example, that are, so if you have a method or a function in a language like C, so that you know, okay, if I call this, what do the parameters have to be? Okay, this parameter has to, this argument, in other words, has to be 0 or greater, this other parameter has to be non-null, that sort of thing. That could be specified as in a comment, and some people will call that an assertion. In other cases, these are very operational things that are checked when the program is running that might check some of those same conditions. Did you folks talk about the operational checking of these as well? So that's what I was thinking, that maybe it's more the sort of specification that's been introduced. Okay, we're going to talk now about a mechanism for actually checking assumptions. And a lot of the assumptions you can be checking have to do with contracts. This notion of that a part of the program, in order to enable flexibility in software development, in order to lower the risk of error, particularly when the program is changed, it's advisable to clearly specify what is accomplished by this portion of the program. Maybe it's a method, what that method does in a declarative way, not all the details on how it does it. You see that if you look at the code, but what it does and what it needs to do that job. So what it needs in terms of preconditions. That's a lot of the use of assertions. It turns out there's some other uses as well. And generally speaking, what they do is they check assumptions. Okay? And they fall into a category of programming called offensive programming. We talk about defensive programming and offensive programming. The goal of offensive programming is to try to get a broken program to fail early and fail hard, so that if there's something wrong, you know it as soon as possible. Now this could sound perverse. Why would you want to make your program crash, as soon as possible? Well, what's worse than having an error is having an error you don't know about. Having an error that may lie hidden until the program is being used by customers, being used by its users. And there's a set of techniques that seek to identify problems as soon as possible. Assertions are one of them. An assertion will be checking operationally your assumptions while the program's running, so that if something goes wrong, it will throw an error. It will indicate it, often with useful information like stack traces that can be made available for you to debug the problem. There's some other ways of doing this too. If you're operating in C or other low-level languages, filling memory that's allocated with illegal values. If you have an enum in C or C++, you wish to, you may want to assign it so the default value is recognized as illegal. So if it's uninitialized, you know it as soon as possible. Filling objects with illegal data just before they're created. There's a variety of techniques for doing this, but we're going to talk about assertions here. And I mentioned sort of these two uses of it. I'm concentrating on this sort of sanity check use. So the idea here is that we actually create statements in your program which say, check this. And in fact, you should get in a habit whenever you're thinking, okay, what is the situation here that my code has to deal with? You should get in the habit of writing those things down as assertions. So what am I assuming? Is this thing a null reference? Can it be a null reference or not? If you're assuming it's not a null reference, then you put down a check. You essentially say, check that it's not null. Does anyone know how you do this most easily in, say, Java as a language? If you wanted to say, check if this is true, and if not, throw an error message. Do people know anything about it? Okay, you can do it with try catches, so that would be a fine way. It turns out that as of, I think, Java 5, may have been Java 6, there's actually an assert statement. And this is what, if you're doing things in Java, or you're doing things in C#, I want to see lots of cases of explicit assertions, okay? And it's a very, it's a specialized statement, it's a special form. And you'll say, for example, you know, assert I is greater than or equal to 0, greater than or equal to 0. And you can have a colon here where you have some error message if it's not, okay? So, you know, index is negative, you know, and it might say check, you know, check such and such data structure. So if this thing fails, if this, every time this runs, it's going to check this condition. And if this condition is false, it will throw an error message with this comment, giving an indication about what line, what place failed, and that will propagate up as a runtime exception until it's caught by a try-catch block somewhere, or until it hits the highest point in the program, in which case it will print out in the console or whatever output you have available. The goal of this is to allow for checking of this and to disable it where required. So it turns out you can turn on and off assertions in Java using Java Virtual Machine commands. Okay, so I think do I have it here? No, I don't have the actual commands, but you can see in later slides. I'll see if I can post today that these things can be turned off through the simple command line argument, enable assertions, and you can actually enable them for some pieces of the program or for the entire code. Okay. So yes,
is enabling and disabling done at runtime or compile time?
It's done at runtime.
Oh.
So you can take the same binary and you can run it with assertions on and with assertions off. Now, why would you want to run it with assertions off? So if you have checks like this, why might you want to run it with assertions off? Okay, so that's one thing. Yeah, sure. See if there's any difference in sort of behavior. Yeah, might be a motivation. What's another reason?
Efficiency.
Okay, efficiency. Because it may not be obvious. In this case, the overhead associated with this. But there might be cases where, for example, I'll give an example from 371. So, how many people in here have used the Click-to-Go or the other app on Saskatoon's transit website? Okay, before that was a speck in the cosmic eye. Before that app came about, there was an app, a bus routing app in 371. Okay? And it actually had people routed among different areas of the city, and you could request that it would take you from one place to the other. Say, I want to go from Place Riel to the airport. Right, accordingly. And they created a fairly sophisticated engine to allow for those routing decisions to take place. And because there was some overhead involved in it, it involved hitting a database, doing some queries and so on, and it had to traverse a graph, they came up with an algorithm that was really clever for doing this. The problem was that it was too clever. You know, when optimizing computers, it's sometimes said optimizing computers is a matter of logical brinksmanship. You wanted to do as little as possible, but still do the required amount. And they did as little as possible, but didn't do the required amount. So sometimes you'd want to take a bus to the airport, and it would give errors. Now, there was an extremely simple algorithm that was a brute force algorithm. What do I mean by brute force algorithm? Yeah, it tries every option. It's sort of, it's just, you know, straightforward loops over all options. Very easy to code, very quick to code, but really a performance hog. You know, really, really slow. Now, instead of doing that, they decided, okay, we'll put in place this clever algorithm. And it took a faculty member to diagnose it, you know, that there was a problem with this algorithm. And actually, excuse me, later in their project, they actually had a feeling something's not quite right here. Now, they could have done with assertions would have been what? Coming back to this issue of why assertions can be performance hungry. What could you do with assertions, clever, that would help you more quickly zero in on a problematic algorithm? So if that algorithm was problematic, they should have wanted to know that as soon as possible, right? Before the faculty member gets to look at it. So what could you have done with an assertion that would have helped speed up that process of diagnosing problems?
The assertion could run the algorithm?
Yeah. It could run the brute force algorithm. It could run the clever algorithm, compare to see if they give the same answer, right? They give or compatible answers. And if not, throw an assertion failure. Now, that could have been really useful. They could have disabled that, put it in a module, disabled that assertion for running the code, in a production way, running it for me or what have you. But they could have found that error very quickly. That doesn't mean they have to rely on the inefficient algorithm as their main algorithm. They just could have put in a check for this that they would run every time they were doing test cases. And they did have test cases that they would run against this. That could have been checked. And it would have shown that problem very early on. They didn't do that. They just put in the quicker algorithm and had an uncomfortable feel that it wasn't working correctly. So that's an example of an assertion use that's more heavyweight, which you'd certainly want to disable once it gets to the user in that case. Now, people disagree. You'll find arguments if you go to Joel on software, other Slashdot, other places where you'll see experienced programmers arguing whether assertions should be retained in a final shipping deliverable. So if you ship a desktop app to people, or you put an app on a smartphone or what have you, should it actually still be running assertions in place? And there's pros and cons to that. If it could prevent, ladies and gentlemen, an assertion, if it fails, will crash a program. Typically, it will crash it. If it doesn't crash it, it will cause loss of some data that was being used in process. If your program is really clever, if your design is clever, an assertion being failed won't totally crash it. It will just pump it up to a level where it writes to an error log, maybe sends email to the team, posts an error over HTTP to some error collection facility so that they know about it, and yet gives a user-friendly error to the person, to the non-technical user. But what would be, suppose it just crashed your program altogether. Even if it's posting logs to logs and so on, it's probably going to lose some data. What's the worst thing than losing data? We talked about it last time. Corrupting data. Permanently corrupting it, yeah. Corrupting a database, which, could mean loss of massive information. Corrupting a file. These things are nasty, folks. Now, in our database techniques with transactions and so on, we have ways of avoiding corruption for some types of operations, but it's still a very real possibility. So, if the presence of assertions, some assertions, not the really performance-hungry ones, but many of the others, would mean that you avoid corruption. It may be worth it. We're going to be talking in class about differences between exceptions, assertions, and return codes, exception signaling, exceptional events that shouldn't be expected to occur. So an end of file should not be signaled with an exception. It should be signaled with a return code. Why is that? Why wouldn't you want to signal an end of file, say, with an assertion? Excuse me, with an exception.
It's not an exceptional event. It happens on a regular basis.
Happens on a regular basis. Another example might be something like out of memory shouldn't be an assertion. Why should you not assert that you have memory available for allocating another object? Why would that be an exception more than an assertion?
It's not something the developer can control.
Yeah, exactly. It's not something under developer's control. You can't simply say, I'm going to pretend that the world has infinite memory and my users are going to suffer or otherwise. That's an exception. It's an unusual thing. You should be able to handle it, to be sure. But should be handled for common expected events. Like you're going to know if you're going through a file, eventually you're going to hit the end. And there's no special language support, but you might want to use some for the return code, something like enums. Is a good way of doing that to indicate in a very distinguished way, a very clear way, instead of just returning 0 or -1. You might want to use enums, which are self-documenting and which afford easy mapping onto more information or more clear description. Exceptions are to be handled for rare events. These are quite heavyweight compared to return codes. Exceptions are, there's a lot of information packed up in exceptions, and actually maintaining try-catch clause so that when you throw an exception, it knows where to go, how high up to go, what the handlers are. It turns out that requires a fair bit of mechanism. There are applications out there that I or my students have worked on where the performance of that application can be slowed down by 10 times because exceptions are being thrown too regularly. And so they are performance hogs, and you have to respect them. It should be for rare events, out of memory. If when you run out of memory, an exception is thrown, not a big loss typically, because hopefully you won't be pounding against that memory limit early. Okay, so these are some common things that might be caught by an exception, by an assertion. Failure to adhere to contract, preconditions, postconditions, invariants. Did you folks discuss those concepts in 370 at all? No? Oh, you did? Okay. Preconditions, postconditions, invariants. Actually, there's a fourth one that's commonly thrown in there. Anyone know what it is? History conditions. History conditions. So if an invariant says this thing is always true, precondition says I need this to be true to do my work, and so you have to keep this true to use me. That's a precondition of my accomplishing my goals. Postcondition is things. If you hold to the preconditions, I will guarantee you these postconditions. Invariant is something. This is always true. This thing is always greater than 0, for example. And a history property might be this thing goes up, only goes up over time. This counter always rises. It never goes down. So an invariant is a property at any one point in time. It's true. A history property is for 2 points in time. They relate in this sort of structured way. Logical oversights by programmers. This is another thing you'll commonly put in exceptions. So, excuse me, assertions. Assertions will be sought to just prevent you from making the silly mistake. So you're assuming some property about this data structure. You're assuming these keys are always consistent or what have you. You never have an empty field within the data structure that the data structure contains all of the items as keys from 1 to n. And then maybe someone later changes your code so that's not the case, and your code would break, and you have an assertion there to check these things. Internal consistency of an algorithm, for example. I spoke earlier about comparing efficient and brute force algorithms, checking the heap is correct, whether a reference passed in is non-null, etc. And that a relationship assumed by the algorithm holds. No duplicate entries. Okay, I think I'm going to go on from there. Let's talk about peer reviews. Peer reviews are, if I had to pull one single thing that is the most valuable thing out of this course, I'd be hard-pressed to get something more important than this, peer reviews. So, again, a peer review is not a review of a peer. It's a review of an artifact created by a peer, typically. And why do we do that? Well, it turns out, ladies and gentlemen, that reviews of code or reviews of other documents like requirements documents or design specs or testing specifications, etc. It turns out that in terms of the bugs found, the defects found, you can find more of them with reviews than you can with testing. You can find it more efficiently in terms of the human time. You might think testing is something that goes on in an automated way and requires very little human time, so how could it be? But it turns out you can spot a lot of things very quickly that would take very ingenious test cases to come up with. They require test cases that will exercise one particular line of functionality that you could reason through more readily. So IBM, for example, did a study, and they found that in terms of human times, 3.5 hours required per defect caught by formal inspections, which are a type of peer review that we'll talk about, versus requiring 15 to 25 hours per error for testing of human time. Why does testing require so much time? Let's suppose I want to use automated testing. Why would automated testing require so much human time? I mean, after all, it's automated. Every time I check my program in, some tests will run what's called a smoke test, and then periodically, maybe once a week or once every few days, or maybe once a day, we'll run a whole battery of regression tests and system-wide tests that exercise that functionality. So why does this require so much human time? Testing.
Right, you ask the scope.
Okay, so often that may be the case, and so that may mean that a lot of tests have to be created, and you only learn over time what needs to be tested. So, okay, you have to create the test. What's another thing you have to do besides creating the test?
Make sure the tests are valid.
Okay, you got to make sure they're valid. You got to test your tests. You don't want the 3 thumbs up, works, and it never even logged in, right? What's another thing you have to do with tests besides creating them up front and testing them up front? Okay, but often that's done. It's true that you will want manual testing to complement your automated testing. There's some things that are just easier to sort of test on the spur of the moment, but often those will lead to automated tests to be created. You'll find some very fruitful strategy, and then you say, let's generalize this and turn it into an automated test. But what else might you want to? What's the vulnerability? Okay, so suppose you put in place a test in incremental deliverable 1. What might happen to that test by the time you get to incremental deliverable 4? Yeah. Exactly. So your program's evolving out from under you. So the test has to evolve with it often. The methods it calls will be different. The data structures may be different. Different classes circulate. You'll do things more efficient ways, and so you have to test it differently. So the tests have to evolve typically. And this is one of the biggest headaches. What's one of the fastest evolving components of a program, ladies and gentlemen? Give me a part of a program that will often evolve quite quickly compared to the others, if you look over sort of the life cycle of a product. Well, often the UI will evolve quite quickly for a variety of reasons. But if you have tests, system-wide tests that hit against the UI, that use tools like Abbott or JRobot to bang against the interface, or even use Water, the web application testing in Ruby, to bang against an interface. What you can have happen is a situation where the interface has evolved so much the test won't work anymore. And for a lot of systems, that can occur very quickly. So if you have JRobot, if you move it by 1 pixel, it can just break the test script. And then you have to go back and fix the test script. And then, the user entering, you move this button over a little bit, and it breaks again. You got to go back and fix all these tests. Now, sophisticated testing frameworks are increasingly being able to abstract over that. And I think Water, for example, and some of the more recent testing frameworks seek to abstract away from the details of, where do you push the button, give the exact pixel coordinates within the scope of a UI. So they try to abstract to a higher level so that it doesn't break all the time. But it's painful. These things evolve. So why do reviews? Well, it turns out they easily pay for themselves. The time saved just way overwhelms the time required to do it. They're more flexible in testing. You don't have to wait till your executable code. And critically, you can address communications issues. You can come to a common understanding of what's going on. Clarity of style, what is the decomposition of work across the program, how does this area of the program work? Ladies and gentlemen, why is that so important? Why is this communication aspect so important on a team like yours? Why not just divide up all the pieces of the program, you do this, you do this, you do this, you do this, and we'll then have it all work together. Why is it so important to communicate across people? Yeah, you avoid the big bang. You avoid, I do my work, I make a perfectly reasonable assumption. You do your work, you make a perfectly reasonable assumption also about how our pieces work together, but they're different assumptions. And so our pieces don't work together. And so if I can learn how your system works, part of the system works, then when I write code that interfaces with that, I'm going to make more intelligent decisions about that code. So spreading of this knowledge about how this area works, how you're doing things, can make people better developers. It can make for a more solid program. And generally, you can sort of spread common understanding about style issues as well, so that you can easily read each other's code without trouble. Give feedback on things like comments. Yeah?
So I'm just trying to clear up the difference between peer reviews and pair programming.
Yep.
Would be that this is pair programming, you're actually creating code. Peer reviews, you're actually just, after you're done the code, you're overlooking it with
Yeah. So you can think of pair programming as being on actually a continuum of review. So this is a form of informal review. It's not totally informal in the sense that probably consciously say, hey, let's do this together. It's great. By the way, I strongly recommend this for your team doing pair programming. You might think it's wasteful. One person's not even got their hand on the keyboard at a time. But it saves a lot of time. It's a lot of fun too. And you learn a lot from each other. You learn how this code works, and you help. One person will often be thinking further ahead or thinking about other issues. And it can really help you a great deal. Ad hoc reviews are just, hey, can you help me take a look at this code for now? Just look over my shoulder, sit down here for the moment. This is takes that to another level. These peer reviews go all the way to formal inspections. Now, formal inspections are a software development industry best practice. And for a formal inspection, and I don't think I'll ask you to look at these slides outside of lecture because there's no way I can go into this level of detail. We'll be going through elements of this later in the semester. But you'll see that these things differ in terms of the different levels of formality in a variety of ways. You'll notice that inspection has yes for all of these. So it requires planning up front. You have to prepare a set of documents before the review to circulate. You have a formal meeting, often more than one. You have to correct the issues, and they have to be verified by somebody other than the person who corrected them. Okay, you'll notice that there's a variety of people involved too. For example, recorders, someone who's leading it, etc. So I noted some sort of less formal reviews here, which include pair programming, although it's not listed there. But here's inspection. Yeah.
We recommend pair programming to us. Is formal inspection too formal for this for the purposes of this course?
You will have to. So everyone in the course is required to go through one formal inspection.
At least one or exactly?
At least one. And this can be done, again, on requirements documents. It can be done on a document describing the build infrastructure. It can be done on test cases. It can be done on post-mortem write-up. But I do want a formal inspection. This is extremely important. And part of the reason it's important to get students exposed to this is because when I go out as part of the internship coordinator, as one of the 2 faculty coordinators in the internship program, one of the things I hear quite a bit is the importance of processes like peer review. That it's important that students be able to go through that ideally before they get any job, because it's an important component, and some students need to get used to it. It's a little bit intimidating the first time you go through it. here's this code you thought a lot about, or here's these test cases you thought about, and then these people are going to review it. But if you can keep the attention not on the attention should not be on you as a person. It should not be on whose fault is this. The goal should be to take a look at the artifact, analyze the artifact, identify issues with the artifact, and then trace back what is it that leaves our project vulnerable to this. If there's a problem, why wasn't it seen sooner? And why did it creep in the first place? It's not about the person involved. Sure, it may have been my error, that I made this error, but why did I make that error? Was it because I didn't have sufficient training? Was it because I was really fatigued and overworked? Is it because there was improper communication to me, outdated information given to me in the form of a document that I was counting on that describes the program? These are all reasons that I might make a mistake. And it can't be a witch hunt where, we're trying to find who's the one who made the mistake. It should instead be, what can we do operationally to fix this? We have to look forward and ask, how could we change things so that we will be less at risk of this sort of problem in the future? And that's not going to be helped by focusing on the person. There have been a couple cases in this class where people have reacted adversely to peer reviews. There's been shouting. There's been a great deal of nervousness. One of my students actually was very nervous about it, and he recommended doing something, having the person whose code it is, or whose artifact it is, do something during the review, while it's going on. He personally liked folding towels for whatever reason, but the point is to not get so sort of worked up on this particular artifact. They can answer questions, but be engaged in something that keeps their mind occupied. That's a way that might work for some people. It's not required for most. The point here is that there is this process of formal inspection. It is an industry best practice. It's been shown to be extremely effective in identifying issues, and you will be responsible for going through this. The student feedback from this is that it is one of the most valuable things that they've seen in their experience as a student. When they go through this, they learn, they get insights about software development, they get insights about how to work with other people's code more effectively. From serving both as the reviewed individual, the author of the reviewed document, and by serving as one of the reviewers. So, see if you can observe these guidelines. You'll want to make sure that you don't plan too much for this. Often you want to plan no more than 100 or 200 lines of code for a 2-hour session. And you want to figure out how you decompose things across different reviews. But I will require indication that everyone here has gone through this. I have discussion of the stages of this, what's required at the planning stage, sort of the overview of the document, preparation of the elements. And I'm not going to be really picky about enforcing all of this, but I want to see something like this taking place. I'm not going to be incredibly picky on was there a follow-up meeting to verify the things were fixed or what have you. Here are some participant roles. Again, this has been a bit looser in this class, but the author shares perspective. There's a moderator who leads the process, and there's a reader who actually presents the pieces of code that's not the author. And then inspectors who can critique code, can identify possible issues, and will typically walk in with some questions because they've reviewed the documents ahead of time. There's recorders and typically 3 to 4 participants. Sometimes the recorder is the same as the moderator, for example. Yeah.
How does one choose lines of code for a review? Is it from a module, from the entire program, cherry picked from classes, or?
So you want to be. So one of the general rules with quality assurance and peer review falls within that category. Processes. You want to pick intelligently because it's typically impossible to do it all. It's impossible to create test cases that will fully exercise the hardware, start to conclude. It's impossible to review. You're not going to be able to review all the code in the time. So what would be some criteria that might lead you to select one piece of code as opposed to another? Significance in terms of, for example, complexity would be a good example. What's another one? Security. So it may be particularly key that this could be a vulnerability that would leave a really bad taste in people's mouths, may compromise a lot of personal information. So that's another good one. Others? The function. Okay, how critical it is, how frequently this is used, or how central it is to the main task the user will undertake. So that's good. Others? Okay. So maybe if there's a method that's really crufty and is 300 lines long or something, you want to take a look at that, because actually the number of errors associated with a method might go up super linearly. What I mean is doubling it in size might mean the number of errors goes up by more than double, because it gets more complex too. It's harder to reason about, and you make more mistakes in your reasoning. The density of errors actually can rise in that case. So yeah, crufty code that's known to be at risk or unstable, code that you've inherited from other places, or that's suspect because of its origins, could be another reason. Another reason is you want to spread information around about this code. Maybe because it's central. Maybe because it's an early risk that you've tried to address, and you're going to be relying on this from now on. So these are things you might factor into your choice of elements of a program. It's just realize, as with testing, you don't just say, oh, test this, test that. You try to be intelligent. You try to get the bang for the buck, the greatest bang for the buck. You try to pick the problem, pick your battles carefully. Dwight Eisenhower once said about World War II. He was a famous general, was key in the Western Front in World War II. And he commented once, someone asked him, what was your key contribution or key strategy in winning the war? He said, I won the war because of the battles I did not fight. He chose carefully what engagements he wanted to get himself into. And so it is with testing, and so it is with peer review. You want to take on the things which will make the best use of your time, that will reduce risks the most, etc. Okay. So what do I expect of you? Peer desk checks. I'd like to see peer desk tests of your artifact per deliverable. I'm not going to force, but one inspection of an artifact is not certain. I like to see people signed off on it. So there should be more than one person involved. Right? Okay, let's talk about risk-driven incremental delivery. So Barry Bain came up with what he calls the spiral model, and this is a singularly dark version of it. I could go into it, I could frob it, but the basic idea is that you create a program in a series of stages, and what's shown here is planning, modeling, construction, deployment, and communication. The thing I want to communicate, though, here is as a key element. I mentioned to you that I want to see incremental delivery. I want to see things built up step by step. And we talked last time about many reasons for doing that. But one of the key ones is to reduce risk. Give me an example of some of the risks that apply for a project. What's a risk?
Won't work.
Yeah.
Compatibility.
Okay, compatibility won't work. Again, won't work is a pretty broad term.
Yeah.
but it can be operationalized in some very concrete ways that aren't really cause you to pause. So some teams in past years have tried to rely on technologies that don't work together. Compatibility.
Well, let's talk about people.
Oh, okay. Yes. Yeah. Okay. So you may want to as soon as possible, as early as possible, try out having two people with potentially incompatible personalities working on the same area, so that if there's a problem, you want to reallocate them to different areas. I suppose you could have something like that. I was thinking technological incompatibility. You're not sure if this thing works with these database systems. You know, you're going to have Merlin set up Postgres for you, but you're not sure how well nhibernate will work with Postgres because it's not documented, for example. Another type of risk is associated with issues having to do with choice of programming language, right? Some years ago, there was a project where one of the stakeholders really, really wanted to use Adobe Flex, and was pushing for that very, very hard, and people didn't really know much about it. There's an uncertainty like that, trying to resolve it quickly so that you can have more lead time to change things is very advisable. So one of the reasons you might choose a certain incremental delivery strategy would be you want to know about a problem as soon as possible so you can head it off by doing something very different. Rather than assuming you're going to be able to do something later in the stages leading up to it and find you're at a dead end. Knowing about it sooner will give you more flexibility. Okay? So you're going to want to do some risk assessment, and we'll talk about that. But you'll also want to reflect after each iteration. Okay, where are we? Where are the big risks going forward from this? And we'll talk more about risk and risk management in a bit. So there's risk-driven, and then there's also value-driven issues. Now, I actually had some slides here, which I was hoping to hit at this point on risk, but I'm wondering if here. Okay, so sorry, folks, I ended up hiding these, and let me just enable them, and we'll just go on for 5 more minutes here. Okay, so first thing is accountable positions. I would like to see clear assignment of responsibilities within this project. Accountability is about taking responsibility, taking ownership of some issue with the project. And lack of accountability, lack of understanding of who's responsible, say, for risk management, who's responsible for scheduling, who's responsible for the build, tends to lead to a predilection for things to fall through the cracks. Things don't get done, not because of malice, not because of deliberate error, but because of you have a sense so-and-so's going to do it, they're assuming you're going to do it. So what I'd like to see here is project manager, design lead, risk officer, someone responsible for daily builds and integration, testing, possibly a triage team. What is triage? Can you tell me? Sorry? Can be involved in healing. It's true. It's a notable term in medicine, but in software development, that it has a different use, and in fact, it relates to the use in medicine. It hopefully yields healing, but what it's focusing on is essentially deciding which of several competing priorities you're going to deal with. And you're often fixing the bugs associated with those priorities. That's right. That's right. So if you're in a emergency room, you're triaging patients if you're a nurse there typically. So patients come in. This patient has had an allergic reaction. This other patient has a possible broken elbow. This other patient has been in a car accident. This patient is complaining of chest pains. Which do you handle first? Which do you let in? Which do you keep waiting? Unfortunately, there's a lot of triage in software projects involving fixing bugs, healing, fixing. Here we have a set of positions: triage, testing. There should be a testing lead. Does that mean all testing goes on by explicit testers? No. Who does a lot of the testing? The developer. Yes, the developer is going to do unit tests typically, and they're going to do some measure of low-level integration testing of their code works with other components. They may do some mocking to make sure it works in isolation, but still with some input from nearby components, and they'll probably test it with other components that have already been checked in. However, testing, there should be a test team who will be doing things like regression tests and doing things like system tests. By regression testing, I mean testing it against past bugs, which may crop up again, or to make sure functionality that used to work still works. Those are two different uses of regression. And testing should also be done by a test team for cases where you want to make sure that the system as a whole is working properly. So the smoke test, for example, which tests basic functionality of the system, and the system-wide test, which demonstrate end-to-end functionality. You log in, you do this, request this task, you do that task, you check the results, you go on and do that. System-wide testing that's exercising many components of the program should be done by a testing team, okay? A risk officer we'll talk in more detail about next time, but basically their responsibility is thinking on an ongoing basis about risk. Risk scanning and helping to prioritize the risk, keeping a top 10 list of risks that can bite us, okay? Ladies and gentlemen, this is not a matter of administrative, this is not an administrative position in the sense that you're just ticking off checkbox. You're not checking off tick boxes either. Instead, what's going on here is you're trying to be intelligent about what could really bite us. And believe me, each semester a team is typically bitten by at least one thing. That person drops, server not available. Sorry? 50% chance I'd say no. I'd say well, yes, there's a 50% chance that, roughly speaking, that you may be bit by something. But if you do a better job with risk management, it won't be a team. You'll head it off. You'll do mitigation, or you'll have a contingency plan. So if this happens, this is what we're going to do.
Drop the class?
Whole team just drops.
Well, you'd be welcome to do that. So design lead should be someone who's sort of in charge of thinking through the integration of the program. Peer reviews, someone should be probably the project manager making sure the peer reviews get done in the context of the class. So I'd like to see each team have a mapping of people to position. You may in some cases want to combine. For example, triage, person in charge of the triage team could be the risk officer. Person in charge of testing could be, for example, a person who's maintaining the daily builds. Although, you got to be careful about overloading too much. So anyway, those are some of the positions. We'll continue on next time with a discussion of proactive risk management. Okay.
What's the lab going to cover today on the presentation? Is it going to be beginning at the beginning?
So the tutorial today, ladies and gentlemen, will consist of 2 presentations up front on potential project ideas. Pretty comfortably without losing 394 content. As far as subsequent triage, you might want to. Right now, Winchell is in Cuba, right? And Dillon City. Is there any chance I could get you to just help out with making sure that that these guest speakers at my simulation course can properly be logged out of a machine?
Okay, sure.
It'll be in 205A.
Okay.
Okay.
Today?
Yeah.
Okay.
Yeah. Actually, I think what I'll try to do. I think it'll be there. I think that's probably the best thing. If you could come by like just a little bit before 4 o'clock to 205A, and then I could basically what's going to happen is I'm going to have two professors.
Yes.
They're going to come and present their idea of projects for 371.
Okay.
And the problem is that I need to leave in the middle of that
Okay.
to go over and start my other class, my simulation class.
Yeah, I know.
And I'm just like I'm afraid if something goes wrong or you know they show up late, I won't be there, and they can't get onto the system or whatever. So it would just be good to have someone there who could kind of help them a bit, you know.
Sure, I'm glad to do that.
That'd be really, really handy. Thank you very much, Wan-Yi.
No problem.
So I should go to the website now?
Yeah, I hope so.
Okay, so let's go take a look. Health Policy Modeling Workshop, is that it? Oh, wow. Okay. Wow, that looks really good. Except it should say fourth. For some reason, English is weird. It right now it says Ford. Do you see that?
Yeah.
So it should probably say fourth.
Oh, okay.
You know, for the digit 4 and then TH.
Okay.
You see what I mean?
Yeah.
At the top.
Okay, yeah.
So let's see. This looks wow. This looks great. So that cost was updated. Is that right?
Yes, and I changed the link of tutorial registration.
Yeah.
If you click that, I think you will go to another page.
Oh, great. Okay. So give me just a second here, because I'm looking. Because another thing we'll want to change is, do you remember? I think remember the information I sent you on the workshop, the PDF? Yeah. So at the end of it, the very end of it, where it says additional information, there's a email.
Oh, yeah.
So maybe you could put that in instead of the modeling tutorials.
Okay.
Wow, this is so impressive. I can't believe you did it. On the left-hand side, there's all these different menus.
Yeah.
How did you figure out how to do that?
I just tried.
Okay, because I think that was something, I can't remember who, maybe Karen couldn't figure out how to make it happen or whatever. So you were able to figure out a way. Man, that's really great.
Yeah, and can I give a suggestion?
Can.
If I am the person who wants to, register workshop 2013, I prefer to put workshop 2013 on the top.
Uh-huh.
And then
Yeah, I agree.
tutorial 2013 and then tutorial 2012.
I agree completely.
Yeah.
Because they're less likely to be coming for the later ones, right?
Yeah.
So could I make a suggestion too? So could you do that? That would be, if you can do that, that's fantastic.
Yeah, I can do it.
Okay, that's amazing. Thank you very much. There's another thing. So do you see how it says tutorial 2013?
Yeah.
That's good. But just the line below that, do you see it says tutorial?
Oh.
Also down at the bottom, tutorial registration.
Sorry.
No, that's okay. That's no problem. Okay, wow, these links look great, Wan-Yi. They're going to this other site very quick, eh?
Yeah.
Holla.
I think that is what you want, right?
Yeah, that's exactly what I want. Wow. Okay, this looks really, really good.
And right now you just need to refresh this web page and I think the order looks good.
Oh, is that right? Oh, yes, you're right. Wow, that's great. That's great. Okay, that's fantastic. So then you might want to go look at the, wow, this is great. So you got the tutorial information download in there too. That's really good, 1E. On 1E.
It's really easy. It's much easier than Java.
Is that right?
Yeah.
So if you could update the contact email,
Yeah, I'll update that right now.
that's great. And then that, oh wow, you changed it to 4th already.
Yeah.
Okay, that's amazing. Wow, it's changing
So fast.
so fast. Okay, this is great. Okay, wow. I'm just browsing this. Okay. Yeah, this is great.
So the email address.
You, at the end of that document, can you see it? I can send it to you also. It's way at the end. Last 2 lines. Okay, I just sent it.
Yeah, I got yours.
Great. Wow. Okay, so I guess the deliverables. Oh, wow. You put the accommodations in here. Eh? That, I mean, in other words, you put it directly in there. That's great, 1E.
You mean the registry stuff?
Well, this alternative accommodations.
Oh yeah.
Yeah.
You can click that and then you can get
Yeah.
that you want.
Wow. That's great. That's great. Man. Okay, that's terrific. So I have just a couple small things when you're ready.
Yeah.
Tell me when you're ready and I can. Wow. So impressed. Wow. You did a good job with this one, fantastic.
Oh, it's just you know, this version is very faithful.
Oh, okay.
So right now for our version we just have one layer of line.
I see.
We can do
Oh, so she did.
3 layers, I think.
Really?
Yeah, and we can insert lots of different video or link or picture. Have you seen the 3 tabs on top, home and travel
Yeah.
contact us? We can add that and we can change it to be a picture.
Oh, really? Okay.
Yeah, it could be very, very
Flexible.
yeah.
Wow, this is great. So you fixed. I see you fixing a bunch of stuff.
Yeah, maybe I'll do some change later on.
So, I'm just going to. I'm Wan Yi.
Yeah.
I'm actually logged in there right now,
Yeah, sure.
but I don't know if. Oh, here it is. Attendees 2013. Then I could delete this. Okay, there's just an extra space somewhere, and then I'll save that. Okay. I kind of like this Joomla. It's kind of nice. Okay, this looks good. So I guess the main thing I need to do is get you deliverables, right?
Yeah.
That's like the only big thing left, true or not?
True. Maybe I can try workshop registration because how do you know it could work correctly?
Yeah, that's a good idea. Why don't you do it as a test or something? And okay, that sounds great. I can't edit, for some reason right now, I can't edit the accommodations and travel. So maybe the Wan Yi can edit it, because I notice on Wan Yi,
Yeah.
I noticed that under accommodations and travel,
Yeah.
it says boot camp. It should say several places it says boot camp. It should actually say workshop.
Okay. Yeah. I'll change it.
And then the email address given should also be changed to the appropriate one. You could see that. Oh, and it says boot camp location. That should be workshop location. Oh, you know what you should do, An Wan Yi?
Yeah.
Before you do that, why don't you actually make a copy of this page? So we'll have one for the boot camp accommodations, and then one for the workshop accommodations.
Okay.
Because this is still good for the boot camp. It's just for the workshop we need to say workshop and talk about the workshop location. But we'll need one also for the boot camp.
Okay.
So can you maybe you want to create a new page, or a copy of it called in Joomla it could be called Accommodations to Travel Workshop 2013, right?
Yeah. I can do that.
Okay, that would be fantastic. Do you want me to work on the deliverables?
It depends on you. I think right now the most important thing is workshop and tutorial registration.
Yeah, to make sure they work, right?
Yeah. So it depends on you. If you are quite busy, then just leave it.
Yeah, maybe for now we take that out
Yeah.
from the menu.
Okay.
Sidyala.
Yeah, I'll do it.
Okay, and that's great. And then maybe you could test the registration. I'm going to actually edit just a few small things, which I probably didn't tell you about, but that will be good. Okay. Sounds fantastic.
Yeah, I'll cue that.
Oh yeah, it's gone. Ha ha ha. Tai hala. Hi ha. Okay. Okay. Great. Ha ha ha. Ha ha ha. Wow. Look at that. It's like accommodations and travel has all these. You know what I'm wondering on Wan Yi though?
Yeah, what are you wondering?
why don't we have an accommodations page and then a separate, travel page? Because like right now, I think putting them on the same page, we don't need to do that.
Okay.
Can we do that?
You mean separate those?
Yeah.
Okay.
So that for the so that for accommodations and travel, in fact, they can share the same travel page.
So you prefer to put the travel page to where?
Well, so travel in directions, those and orientation information. Those could go to a separate page called like travel, something like that. Travel, and then there, instead of being accommodations to travel, it would just be accommodations.
Okay.
Does that make sense?
Yeah, it makes sense.
Yeah. Sorry for the trouble, but that would be great.
So I just separate those and put the travel page into workshop 2030 or on top of the just beside the
Travel can go just before workshop registration, I think. Does that make sense? Yeah. Wow. This is good. Also, Wanyi, in workshop design, there's also something that says like logistics. You see there's something called, you don't have to look right now, but in the workshop design one, there's something in logistics. That should probably be in the travel section, because it's about traveling.
Oh, okay. Oh, I see.
And then probably there should be a financial page.
Yeah, so the financial page.
Because in workshop design there's financial right now.
Yeah, I know. So put financial to be a separate also?
Yeah. And then I think and then we'll want some page to link to the orientation information, for that. So tell you what, I'm going to go use the washroom right now.
Okay.
And then I'll call you when I get back in a couple minutes.
Sure.
Okay, thank you so much. This is a huge step forward. I thought I was going to have to do this myself.